Okay, so today we're reviewing over the section 1.9 from your textbook, which talked about describing locations within a distribution. You were asked to read the section and to take notes as well as tackle a few of the exercises. So let's take a moment and go over the notes, and you were asked to look at for important concepts. One of them, percentiles, which is a way to describe a location. And the percentile describes the percent of values within a distribution that are less than a given value. For example, if we were looking at the 85th percentile, that would mean that 85% of the values are less than the given value. The values are less than given. If we were looking at the 22nd percentile, so the 22nd percentile was 300. So if the 22nd percentile was 300, and 300 is greater than 22% of the values. So there are 22% of the distribution that is less than 300. Now, one of the things to remember is that a percent describes a specific location within the distribution. So a value is at a percentile, it is not in a percentile. That's very important. Okay, now remembering that percentiles describe the percent of values less than the given value brings the interesting question is, why is it impossible for a value to be at the 100th percentile? Now, if we follow the definition of the 100th percentile, that would say the 100th percentile would mean that 100% of the values are less than our given value. Now, that would arise the question, can a value be less than itself? So, can a value be less than itself? No, of course not, it can't. So the 100th percentile would be impossible because the given value cannot be less than itself. Okay? All right, so the 11, it's impossible because the given value, a value, cannot be less than itself. Similar token would apply to the 0th percentile. So the highest percentile you can have is the 99th. The lowest percentile you can have is the 1st. So now we've talked about box plots, which talk about the quartiles. So knowing what we know about the quartiles, let's describe the quartiles Q1, Q2, and Q3 in terms of a percentile. Now we know Q2 resembles the median. The median puts half the data above it and half the data below it. So it is in the middle. So Q2 would be the 50th percentile. So now if we're looking at the divided half, so we just look at the lower half of the data, which would run from the 1st percentile to the 50th percentile, and Q1 falls in the middle. The middle there would be the 25th percentile. And by the same token, in the upper half, Q3 would be the 75th percentile. And if we were to continue that logic just for giggles, the minimum, which is the smallest value, so every value is greater than it, we would assume is the first percentile. Because remember, you can't have the 0 and the max, because all values would be less than the max. We can't have the 100th, would be the 99th percentile. So, ladies and gentlemen, that is the idea of percentile, dividing it into chunks of data. So moving on, so if we put that into practice, we look at the first exercise you were assigned over the weekend, over the last Thursday or Friday. Is here we have a dot plot that is representing the number of wins for each of the 30 Major League Baseball teams in the 2014 season. So if we're asked to find the percentile for the Boston Red Sox, who won 71 games. So they won 71 games. So we look on our dot plot, and we locate 71. So this is Boston. So percentile is the percent of values less than the given value. Our given value is 71, and if we count the values less, 1, 2, 3, 4, 5. We know there are 5 values less than 71. So the percentile would be 5 over the total number of teams, which is 30, which is equal to 0.167 for the 17th percentile. So Boston is at Boston's 71 wins. Boston's 71 wins is at the 17th percentile. Now, it would be acceptable to say the 60th percentile here, depending on how you chose to round 1.67. So that's taking a given value and calculating the percentile. How about going the other direction? If we know that New York is in the 60th percentile of the distribution, that tells us that New York won more games than 60% of the teams. We know then, but we also know that there were 30 teams in Major League Baseball. So the 60th percentile leads us to 0.6 or 60% times the 30 teams gives us 18. So using that logic, we can now write a new conclusion that New York won more games than 18 other teams. Okay, so now we know that New York had more wins than 18 other teams. So that means whatever dot in our dot plot represents New York, 18 of them have to be less than. So that means if 18 of them have to be less than, that means, so I'm going to have to use a different color here. I'll have to go with black. That means New York has to be the 19th dot. So we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So double check that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that looks at New York won 97 games. And just to recap and break that down, the 60th percentile alone was able to tell us that they won 60% of the, better than 60% of the teams. But since we know how many teams there were overall, we were able to show them that there were 18 teams with less wins than New York. And because we have the actual data in the dot plot, we were able to count it out to determine that New York won. Oh, I'm not sorry. It's not 97. That is 87. I misread my scale. But we were able then to see that it was 87 games. And so that brings us how to look at percentiles and calculate both directions. What is the percentile it is at? And what is, okay. So now let's talk about cumulative relative frequency graphs. A cumulative relative frequency graphs is a display that provides a summative total. That means we are adding. Summative total means we are adding of the relative frequency of each interval within a quantitative distribution. Okay, so cumulative frequencies, we're starting at the smallest interval with the bottom end, the lower bound of the smallest interval, the least interval would start at 0, and it would rise to the upper bound. It would reach whatever relative frequency was between, in this case, between 50 and 55, 10%. Well, the next category doesn't mean that from 55 to 60, it's at almost 20%. What it means is we added the percentage of 55 to 60 to the relative frequency for 50 to 55, and now we're at 20%. And we keep adding each interval until we reach the value. We would then reach 100%, because it would never be more than 100%, because you cannot have more than 100% of the data in the plot. So if we were at this point asked to know what percentile is $75,000 at? What percentile is $75,000? So we would go over, because 75,000 is a median income. It is what is measured on the x-axis. So we'd go over to 75. We would rise up, and then we would go across just a little bit above 30. So we'll call this at the 31st percentile. By the same token, we can use it to go the other way. Perhaps we want to know what is the median income at, the 60th percentile. What is the median income at the 60th percentile? So, okay, so we go percentile is relative frequency, summative relative frequency. So we're able to look on, and this should be a cumulative. Correct that real quick. So we go up to 60%, we go across graph, and then we go down just past 80%, 80, not quite to 85, looks about 81, 82. So the 60th percentile, because remember our median income is measured in thousands of dollars, the 60th percentile, 82,000 would be at the 60th percentile. And that's how we read a cumulative frequency graph. So if we put that into practice, we'll look at number 5 from the practice. I'm aware that I may have signed number 4, which was an error, but we're going to look at number 5, which is here, which shows the cumulative relative frequency graph of the amount spent by 50 grocery shoppers at our store. Our first question is, what is the percentile for the shopper who spent $19.50? So we'll go over to $19.50. That's amount spent, so that is on the x-axis. It's quite a 20, so we'll come up right here and come across. And it looks like we are at 20. So the percentile for $19.50. So spending, writing our sentence here, spending $19.50 is at the 20th percentile. So this is definitely a low amount spender because only 20%, 20th percentile, 20% spent less than $19.50. So now looking at part B, asks us to estimate the 80th percentile of the distribution. So now we're starting with a percentile. So we'll go on the y-axis. Here's 80. All the way across till we hit the graph. All the way down. So it looks like the 80th percentile, so estimate is 55,000. So, oh, sorry, 55. So spending $55 spending is at the 80th percentile. That, ladies and gentlemen, is how we look at both what a percentile is and how we can use a cumulative relative frequency graph to estimate. So now I would like you to go ahead and look at the practice set from your textbook. I don't recall what the exercises are, but they are posted in the Google Classroom. And be ready to have that in class next with questions and be entertained. Thank you very much.